Good morning, students.
Good morning, sir.
Morning, sir. Morning, sir.
Good morning, ma. So 40, 41 numbers, right? Yesterday we discussed about that organic chemistry part. In that, the fundamentals, we discussed that one. That is the classification of organic compounds, how they are classified in the broad classification. Then after, we have discussed about the functional groups. On the basis of the functional group, the organic compounds are classified again. We have discussed that one. So important is the functional groups. Without knowing of the functional group, you can't do anything in the organic chemistry. That means functional groups are very, very important. On that functional group, how you are calling the name of that compound. The functional group is important. Next, coming to the US examination question, that is the hybridization concept. So we are discussing the sp3 hybridization, sp2 hybridization, and sp hybridization. So sp3 already you know that the definition small. Sp3 in that only there one is s is there, 3p is there. That means one spherical shaped s orbital, 3 dumbbell shaped p orbital mixing each other to form 4 sp3 hybrid orbitals. These 4 sp3 hybrid orbitals are arranged in a tetrahedral manner. This tetrahedral manner means the bond angle is 109 degrees 28 minutes. For this is sp3 hybridization. The example is we are taken as the methane as well as the ethane molecule also.
Page number, sir.
Like that, the sp2 hybridization. sp2 means sp2. One is s orbital is there, 2 are p orbital. One spherical shaped s orbital, 2 dumbbell shaped p orbital mixing each other to form 3 sp2 hybrid orbitals. These 3 sp2 hybrid orbitals are arranged in the trigonal planar model. Okay, trigonal planar model, making of the bond angle is 120 degrees. That is a bond angle. For this, we are discuss the example is ethylene molecule. Ethylene means ethene. You can pronounce as a ethylene molecule is a general name is the ethylene, but is the actual IUPAC name is ethene. Double bond is present between the carbon. So that here in this participation of the p orbital, only 2 p orbitals are participating in the hybridization. One pz orbital, pure orbital is still present on the these pz orbitals. That means unhybridized p orbital, pz orbitals are lateral overlap takes place, formation of the pi bond is present. Students, don't interrupt our class. If your discussion is there means please leave the class and discuss it, and mute your all devices please, because I will go to the some little bit of fast because the portion is heavy is there. We are in that particularly second block only. We are still in that organic part. Organic part takes so much of time for me, okay, to discuss elaborately. So like that you are discussing about the sp hybridization also. The ethylene molecule are discussing in that example. Here in the ethylene molecule means the carbon triple bond is present on this carbon atom. Only one px orbital is hybridized. The remaining 2 py and pz orbitals are unhybridized orbitals are present on each carbon atom. These unhybridized p orbitals, lateral overlap takes place, formation of the 2 pi bonds. That's why you are getting a triple bond. Triple bond means in the sense of the 2 pi bonds are there. One compulsory the bond is present between the carbon and carbon, that must be a sigma bond. The bond is formed. Then only After the formation of the sigma bond, pi bond is formed. If the unhybridized p orbital is present, that is why Leslie molecule are discussed. The next topic is very important topic again. If you are understand this concept, then organic chemistry is a very easy. That is nothing but the nomenclature of organic compounds. How to nomenclature? That is the IUPAC rules are there, the nomenclature. So please listen carefully. What is the nomenclature? How we are discussing that compound? To name it come. Before that, we have discussed about the urea, acetic acid, ethyl alcohol. These are already I told that these particular names are derived from their history. That means they are obtained from the sources. Urea is the mammal, urine is consisting of urea. That's why the name as a Oler by the urea. And the henel, yes, nothing but we are getting of the henel is that is a wood destructive distillation. From the wood destructive distillation, we are getting of the wine. That is the alcohol. That's why it is called as the ethyl alcohol. E2O, ethyl alcohol. Similar manner, coal is named as the acetic acid. That is a because of the acetum. Acetum means it is a vinegar is present. Acetum, that is a acetic acid, is called as the acetic acid. Okay, like that the history is present. So many other compounds are adding up. But after the latter in the 19th century, so many organic compounds are synthesized. So that our chemists, whatever they have put as a society that is called as IUPAC Society, Indian Union of Pure and Applied Chemistry. Before that, so many societies are established, but they not complete the whatever the rules. After the completion of that one in the 1950s to we are getting of the IUPAC nomenclature. That is the International Union of Pure and Applied Chemistry. They derived some rules. On that rules, we are framing of any organic compound. Now the nomenclature of organic compounds. So the classification mainly important the nomenclature depending on that one. So we are discussing about the nomenclature. Nomenclature of organic compounds. Friends, here nothing is there. This one, just listen carefully. How to name a organic compound? Unknown organic compound means take unknown compound, organic compound. That organic compound, I am dividing. That means the substance is not dividing. My purpose for naming purpose, I divide into 3 types. First is called as, please listen carefully. First is called as root word. First, the organic compound is divided into 3. One is called as a root word. Another is called as primary suffix. And third is the secondary suffix. Sometimes we are having up in between only, but I am writing in the 4th one, but here only you can write as prefix also. Okay, these are the words I am using for the naming of organic compound. Please listen carefully. Here only you are getting of complete clarification of the organic compound. What do you mean of this particular all the things for the naming of organic compound means? See friends, here this is a root word. Root word indicates in a given organic compound how many number of carbon atoms are present. That's it. The simple root word indicates what? How many number of carbon atoms are present in a given organic compound is called as root word. So already you are familiar with, if 1 carbon is present, that is called as a meth. If 2 carbons are there, that is called as a eth. If 3 is there, it is called as a prop. Yesterday you learned that one, the Greek words. Okay, the root word indicates what? Number of carbon atoms in a given organic compound. Whatever the compound is given to you, you have to naming means first you have to divide what is the compound. What is the compound consisting of number of carbon atoms? So 1 is there meth, 2 is there eth, prop, bute, pent, ex, hept, oct, nun, and dec. These are the you are learned already in the yesterday. Same thing you are using of this one. Prime, that means root word. Now coming to the primary suffix. Most of the teachers will say the first prefix, but I don't want to say. Why? Because you can understand that. See, I'm using a first primary suffix. the given organic compound, in that you are identify the number of carbon atoms, right? Then you feel that given organic compound, whether it is the carbon is arranged in the single bond or, sorry, some disturbance is there. The carbon atoms are in a given organic compound, you are identify the number of carbon atoms. Then next is the primary suffix. You are finding the primary suffix indicating that the given organic compound consisting of the between the carbon and carbon, whether it is a single bond or double bond or a triple bond. If a given organic compound consisting of a single bond, it is called as a primary suffix is called as A. If a given carbonic compound, the carbon, a double bond is present. A double bond is present. Disturbances are going on. So the primary suffix indicate if a given compound is saturated one, it is called as a N. Unsaturated means it is consisting of double bond, it is called as a E. If it is a compound consisting of triple bond, it is called as a I. That means the root word you are identifying, the number of carbon atoms are whatever the number, 4 or 5 or that is it is called as alk. Alk is the root word. Now the primary suffix is also identified. It is a single bond is there. That means saturated one means you are putting of root word plus primary suffix alkane. See the friends, the naming is alk plus ane means suppose if you are identify the carbon atoms are 4, but plus ane, butane, finish. The name is over. Okay. Now that means the root word is the common is the name is alk. And the primary suffix is depending on the saturated or unsaturated. Now I'm coming to the secondary suffix. What is the secondary suffix here? This is the important of the secondary suffix. So I'm using of the secondary suffix before. The secondary suffix is nothing but the functional group. What functional group is present in a given organic compound? If the functional group is OH is there. If the functional group is OH, already I told that this is alcohol. So you are naming as it is a alcohol. It is called as OL, mainly important, alcohol. Now, if it is a compound is aldehyde, if it is a aldehyde, it is, you are using as Al. If the functional group is carboxylic acid, it is a carboxylic acid. So, you can call as this is the oic acid. If the functional group is ketone, if it is a ketone is there, it is called as one. One, not one. One. That is the pronunciation is one. Okay. Oic acid. One. Like that. Suppose already we have learned that first root word is alk. And that given organic compound is a saturated one. Ane. Suppose in that the secondary suffix is carboxylic acid is there. Oic acid. Now the name is, just remove the E. Alkanoic acid. Alk, AN, this one, oic, alkanoic acid. Okay. Suppose friend, here, if it is a but is there, means butanoic acid. Suppose it is a pentanoic acid. If it is a 2 are there, ethanoic acid. Like this, you have to during of this particular nomenclature. These are the 3 are very, very, very important. Root word means number of carbon atoms. Primary suffix means whether the given compound is saturated or unsaturated. And depending on that one, you are using of the names. This is a, if it is a saturated one, ane. If double bond is called as ene. If triple bond is called as ine. Suppose the given organic compound secondary suffix is alcohol, it means you can call it a methanol. Suppose the organic compound, one carbon is there. It is a saturated one. Meth plus N plus OL, methanol. We are writing. Okay. If aldehyde is there, meth plus Al, methanol. These are the pronunciation is same, but it is the aldehyde group is there. See, be careful about this alcohol and also particularly here aldehyde. You have to remember carboxylic acid means oic acid and the ketone. These are the very, very important secondary suffix which are used in our organic chemistry to getting of the organ. That is a nomenclature of IUPAC name. Okay. Next, I already told that the fourth one is our prefix. What is prefix, sir? I told that it is, I will explain the latter last only, but most of it is given in our book also. It is the first one. Prefix is the first. Next root word, next primary suffix, next secondary suffix. The first mention the prefix. I don't want mentioning the prefix. Why? Because you are not identifying. How are you getting out the prefix? Prefix indicate what? What are the substances present in a main compound? What are the substances is present in a main compound? I will write one example. I will explain this prefix. Suppose the given organic compound is like this. So friends, here the skeleton, I am writing the skeleton. Skeleton means without having of the hydrogen atoms. So here one bond is there. Remaining will be filled with the hydrogen atoms. 3 bonds, 4 compulsory on each carbon atom. Here 2 bonds are there. Remaining will be filled with the hydrogen atom. Here 2 is there. Remaining filled with the hydrogen atom. Here 2 is there. Remaining filled with the this one. Suppose here also we are having of the some group is there. Functional group is present. Suppose I am using of the functional group. Let us see the name. First, what is the name? First, find out the root word. Root word means number of carbon atoms. See friends, how many number of carbon atoms? 1, 2, 3, 4, 5 is there. So our root word alk is what? Pent. Or got the points? Here, first identify the number of carbon atoms. 1, 2, 3, 4, 5 are there. It is a pent. It is a saturated. Single bond is there. So means it is a pentane. We are removing the E. Now there is a functional group. There is a functional group is there. What functional group is there? Aldehyde is there. So you can pentanaldehyde you can write. Or the small word pentanol. Also same. It can also write as pentanaldehyde. Pentanaldehyde. Both are same. But the simplification, this one is there. This is, you are coming off all the 3. Now I am using off one more. Removing of one hydrogen and keeping of one substitution. This is called as a substitution. So friends, I am using the one methyl group. Methyl group is present in this particular case. Now the methyl group is there. This methyl group is called as a prefix. Any substituent is present in the main chain or main organic compound. First write the prefix only. You have to write the prefix first, then after the alk plus an plus secondary suffix. That's why in your book it is given as a first number only. Prefix is a first number. But first number you can't identify initially. Only lastly you are identify that particular substitution. So substitution is present here. Now this is the first carbon atom, second carbon atom, third carbon atom, fourth carbon atom, fifth carbon atom. Okay. So friends, here 1, 2, 3. At third position, one substitution is there. That means in the main trunk, a tree is there, main trunk, the branch is there, the branch. This is called as a branch. Branch at what position is there? Third position is there. So it is called as 3-methyl pentanaldehyde. The name of organic compound is. I hope you clarify this particular example. Okay. 3-methyl pentanaldehyde or pentanol simply. So why I am writing like that, sir? Why can't here, sir? Again, you are a big question. You are writing from the right to left, not left to right. Why you are using means I will again clarify that doubt. Why? Because the rules are there. Some rules are there. Before that, but here I want so the fourth classification is the prefix. For the prefix purpose, I am using this particular example. Here the substitution is present on the main trunk. That means if you are tree, the trunk is there, and the trunk one branch is present. The branch is called as a substituent. Substituent on which carbon is there means third carbon is there. So it is called as a 3-methyl pentanaldehyde. I hope you can clarify that. So this is a very important classification of that one. In that classification, you can name it as any organic compound. But finally, getting of the organic compound, IUPAC, that means International Union of Pure and Applied Chemistry Society, is given some rules. The rules are very simple rules. I will explain the rules, that is particularly after this one. I hope you are clarified this one. The 4 parts are there: root word, primary suffix, secondary suffix. According to your book, this is the first one: prefix, root word, primary suffix, secondary suffix. Okay. Now coming to what are the rules? The rules are very important. One rule is identify longest chain. Identify longest chain. I want in a given organic compound, you can identify the long one. Suppose I write one example for this one. Just I am writing the skeleton only. This is a skeleton equation I am written. Okay. Now find the longest one. Sir, 1, 2, 3, 4, 5, 6, 7. 7 are there, sir. It is the longest chain. Whether it is longest or, you see, a straight chain is consisting of the 7 carbon atoms. But if you go to the like this, the way you are path like this, 1, 2, 3, 4, 5, 6, 7, 8. Which is the long? 8 is the bigger one. So you have the branched chain is the longest chain, not straight chain is the longest one. That is a very important. Identify the longest chain, whether it is straight chain or branched chain. We don't want. So, but the either condition is the longest I want. So you are getting up. This is the longest chain. So 8 carbon atoms are there. That means 8 carbon atoms are there. Means what? The name is, the root word is what? It is a oct. Okay. Here these are the saturated one. Oct A. Primary suffix is over. Root word is over. Secondary suffix, anything is there? There is no secondary suffix. No functional group is there. But there is no functional group is there. But we are having the first number. That is your Bukas. That is the 4th one. A substitution is there. Substitution means prefix is there. Prefix is present here, the carbon atom. So methyl octane. I'm not using the number. Okay. Methyl octane. Now use the number. Whatever the substituent or branch, according to our concept, branch or methyl or substitution present, that must be present in the least numbered carbon atom. The second rule is what? You are writing the substituent, that is the prefix name, that must be a least number carbon atom. Suppose a student is writing the, sir, this is the longest chain. Now I am writing the number 1, 2, 3, 4, 5, 6, 7, 8, sir. Right. Now, according to your idea, I am writing the number also. So friends, here 1, 2, 3, 4, 5, 6, 7, 8. It is a longest chain, sir. Now that is a oct, N is obtained. But here the substituent is present on which carbon atom? 6th carbon atom. The substituent is present on the 6th carbon. While you are writing like these numbers. But suppose if I am writing off these particular numbers as 1, 2, 3, 4, 5, 6, 7, 8. From this side also you are getting the same 8 numbers. But here the whatever the substituent, the branch is present, but it comes under the 3rd least number atom. So that whatever you are using of picking up first initially, it is a wrong one. So it is a wrong one. This is the correct one. That means it is a 3-methyl octane. Okay, friends. The second rule is the substituent or prefix must become least numbered carbon atom is given as this one. And in the third rule also, I'm using in that 1, 2, 3. But it is not given in a book. Only one rule is given. Identify the longest chain. But not given as this, where the substituent must be present in the least number carbon atom. Suppose more than one substituent is there. Your already second rule is fulfilled. That means least carbon atom only the substituents are present. But the number of substituents are more than one. Then you can write according to the alphabetical order. Suppose chlorine is present. Here the chlorine is present. The chlorine is present means we have to write that one on the same third carbon atom only. Here I am writing. Okay, I am written on the same third carbon atom. One branch, two branches are there. One is the methyl substrate, another is the chlorine. Which is according to the alphabetical order? C is chlorine is the first. Next is the methyl. So 3-chloro, 3-methyl octane. That is the third rule. Understand the friend? So main important is identify the longest chain, whether it is straight or branched one. Second is if the substituent is present, the substituent must be comes on least numbered carbon atom. Least number. Takwa sankhya unna carbon degara a substituent methyl substitution kani leda halogens kani sometimes alcohol substitution also వస్తుంది. మధ్యలో OH ఇస్తాడు. అది తక్కువ సంఖ్య నంబర్ ఉన్నప్పుడు అప్పుడు అలా మనము ఐడెంటిఫై చేసుకోవాలి కార్బన్ల సంఖ్యను. మనం స్ట్రేట్ చైన్ గా రాసేటప్పుడు స్ట్రేట్ ఒకటే రూపము చేయదు. అది లెఫ్ట్ సైడ్ అన్న కావచ్చు, రైట్ సైడ్ అన్న ఎక్కడి నుంచి రాసినా కానీ ఏం కావాలి మనకు ఆ సబ్స్టిట్యూయెంట్ లీస్ట్ తక్కువ నంబర్ గల కార్బన్ దగ్గర ఉండాలి. అది సెకండ్ రూల్. థర్డ్ రూల్ ఏమని చెప్తున్నది, రెండు సబ్స్టిట్యూయెంట్ ఉన్నాయి అనుకోండి, ఒకటి కాకుండా ఎక్కువ సబ్స్టిట్యూయెంట్ ఉన్నప్పుడు అప్పుడు మనం ఏంది డిక్షనరీ ప్రకారం ఆల్ఫాబెటికల్ ఆర్డర్ లో రాయండి. అది ఎక్కడన్నా ఉండని, కానీ సబ్స్టిట్యూయెంట్స్ ఆల్రెడీ ఫిక్స్ చేసాము, మినిమం నంబర్ కార్బన్ లో ఉన్నట్టు ఫిక్స్ చేసాము. మనం రాసేటప్పుడు మాత్రము సపోజ్ ఇది ఈ క్లోరిన్ ఆటమ్ ఐఎమ్ యూ రైటింగ్ ఆఫ్ ఇయర్ ప్రెసెంట్. Don't worry about that one. Why? Because one substituent is the least carbon. Suppose here 1, 2, 3, 4. It's the fourth carbon atom. Fourth carbon atom is the least carbon atom. Least substituent. So this is the correct way. Third methyl and 5-chloro. 5-chloro, 3-methyl octane. Right? You are like me. Okay. This is about the third rule. Now coming to the fourth rule. That means according to your book point of view, it is the second rule. If functional group is present, if the functional group is present, so friends, here using of this one, the number, if functional group is present, you must prefer the functional group only. Let us see, discuss about this one example. I'm written this particular structure, skeletal structure. How many number of carbon atoms? First, select the longest chain. 1, 2, 3, 4, 5, 6 sir. Here branch 1, 6. Now straight one 1, 2, 3, 4, 5, 6 sir. It is also straight chain where is consisting of also 6 carbon atoms. So 6 carbon atoms are writing. That means 1, 2, 3, 4, 5, 6. Or you can write this is 5, 6. Which one is correct? Only straight chain is correct. Why sir? Because a functional secondary suffix is there. The secondary suffix must be included in the longest chain. The secondary suffix must be included in the longest chain. That is only the main concept. The second rule is nothing but if functional group is present, you have to prefer the functional group. And also the numbering. The numbering is, it is also wrong numbering. The numbering must be, it is also the numbered must be. It starts from the functional group, not from the other side. So the number must be right. 1, 2, 3, 4, 5, 6. Or you can suppose 1, 2, 3, 4, 5. This is a 1, 2, 3, 4, 5. This branch is not the longest one. It is only straight chain is the longest one. You are getting. Just now I used the first example I given as while starting of the nomenclature. So the whatever the functional group is there, the functional group, the number should be start there only. Blindly start the number from the functional group of the carbon atom. Here carbon atom is present in the functional group. Suppose our OH is there. OH is not consisting of the carbon. Please remember the rules are applicable for the when the functional group consisting of the carbon atom means aldehyde is there, acid is there, ketone is there, that is included in the longest chain. And also it's first present, prefer the first only. You are preferring the first carbon atom. So this is the longest chain. Now see that one particularly. What is the root word? Root word is the 6. Means what is the name of this one? It is a eggs. It is the primary suffix is a and secondary suffix is what? All. That is the al, hexanol or hexanaldehyde. Okay. But here the substituent is present on the third carbon. Substituent what? 2 carbon atoms means it is a CH2. It is CH3. Total comes under C2H5. C2 means C means 2 means ethyl. So ethyl is present at the third position. 3-ethyl hexanol. This is about the condition of your particularly writing of the functional group. Okay, friends. So you are remember the very important is the identifying the root word, that is the largest chain, and also root word. Then you can take it as the consideration of the functional group. Functional group prefer that one that will be getting off your position. These are the rules which are having off in the nomenclature. I hope that one you can practice some 2-3 examples. We'll give that one. From these rules, you can easily write the name of the compound. So this is a skeleton equation. By filling out this one means it required 3 more hydrogens. It required 2 hydrogens. It requires 2 hydrogens. Here also it required 2 hydrogens. See, this is one simple example. Selecting the longest chain means it is the longest chain only. Straight one. I have not written anything in the branched one. But the number, how to write the number? You first prefer the functional group. You blindly write here one. Blindly. I am saying that functional group is there means write number 1 here only. Don't see anything. First write here. Then go to the whether it is straight or branch. This is the second, third, fourth, 5, 6. So root word is what? X. Primary suffix is A. What is this? Is the secondary suffix is oic acid. Hexanoic acid. How it is simple. Please remember that one. My concept is first select the root word, identify the root word. Next, primary suffix means it is saturated, unsaturated. Next, secondary suffix if it is present. If it is present, you have to prefer the number from that one. I have given as a list of OH is there. It is called as a OL. If CHO is there, it is AL. Or you can write alcohol or aldehyde, no problem. If COH is called carboxylic acid or oic acid. If C double bond, that means CO double bond O is there, one. That means it's a ketone is there. It is called as a one ketone. Okay. So like that you are using of hexanoic acid, right? Next, I'm using of the same word. Now friends, numbering. Substituent must be present according to the longest chain. Identify the longest chain. 1, 2, 3, 4, 5, 6, 7.
Straight chain.
1, 2, 3, 4, 5, 6. 6 is the longest chain, right? X.
Long.
And second rule is
Yes.
prefer the least number carbon atom the substituent. If it is the writing of here, second position is there. It is the least carbon atom, that is the substituent is present. But the third rule is what? That means both are there. Fourth rule is according to fourth rule. If functional loop is there,
We have to
it
give
will must be taken as a consideration of the first preference. So kindly write the name here only. If your second rule is violated, even though you are violating the second rule, but the first you have to prefer the function. Second suffix is that much of important. First write simply here. Now see, on the third position 3-chloro, and the fifth position 5-methyl. X is there. Root word primary suffix is N is there. Oic acid. So 3-chloro, 5-methyl, hexanoic acid. Very simple one. Next we will take the one more example. See 2, 4, 2, 3, 4. 1, 2, 3, 4. Every carbon is as a 4 bonds. Now see the number. It is every time it is repeated question. This one repeated one. The example is given. So how to number? Where is the position? Where is the how many number of carbon atoms are there? The root word is 4. But. And the second one, that's the primary suffix is. There is a primary suffix is the in is there. In is there. It is N is there. But the position of this one here, the one carbon 2 carbon, 3 carbon, 4 carbon, or 1 carbon, 2 carbon, 3 carbon. Anywhere you can write. Either this side or this side. Both are same. So here using of this one, and which carbon we are having of that one, the double bond. One first carbon, a double bond is there. Again the third carbon, a double bond is there. Here also first carbon, a double bond is there. Third carbon, a double bond is there. The name is 1 3. Why I am writing 1 3? These positions are 2 times repeated. At first position carbon atom as well as the third position carbon atom, 2 times the ene is repeated, double bond is repeated. So I am writing at the same time 1 3. It is a di. Di means 2, tri means 3. Okay, so 1 3 di. What is the root word? 4. Buta. So 1 3 I am using of this butadiene. This is the name of this compound. 1 3 butadiene, or you can call as 1 3 diene butane also. 1 3 diene. Why? Because I am using of the substance is present at the first carbon as well as the third carbon, are called as a ene. Diene is there. Next is the root word is 4, and the primary suffix is ane is there in the middle one. It is called as a butane. At ene is where the position is there at the first carbon atom as well as the third. Both are the same names. It is a according to the IUPAC nomenclature. We can write as it is a 1 3 butadiene also correct, and 1 3 diene butane also correct. Depending on the but pronouncing in the generally we are using of in the our third chapter we are having of 1 3 butadiene. There is a dienes are there. It is generally pronouncing a 1 3 butadiene. Like this, these are the examples which are present in the nomenclature. I hope you can follow this nomenclature. Main important prefix. Prefix means it is a substance. The substance must be present in the least number carbon atom. First write the prefixes only. Prefixes means the substances are present in that one and making of alphabetical order. Then find out the identify the root word. Next is a primary suffix. Identify the primary suffix. Next identify the secondary suffix. After the identification of the over, you can prefer if the functional group means secondary suffix is present in a main chain or in an organic compound. Prefer the functional group. If the functional group is not there, here the functional group is not there, I'm not preferring. I can write either this or this. Both are same. I'm not preferring that one. Okay. If the functional is there means you can prefer there only. You can blindly write the number 1 there only. You give the preference. Right, like you are getting of the these are the rules which are having. Okay, friends, in our examination, it is asking for the 10 marks question again. So you have to take as what is prefix, what is the root word, what is the primary suffix, what is the secondary suffix. Then the rules are identify the number of carbon atoms, longest chain first. First identify the longest chain. Next, what is the root word? Next is the what is the substance is there which is comes under the least numbered. Next primary suffix is what? Next is the secondary suffix. Okay. Now we'll go to the one more other question, that is a long question, 10 marks question again, isomerism. What do you mean by the isomerism? Actually, it is a Greek word, isomers. Greek word. This is particularly Greek word. We are using of this one. It is nothing but isos means equal. Meros means parts. Equal parts is present in a given organic compound. Words are, we don't understand that one. Let us see. Nothing to worry about that one. The word, whatever the word is given as, we don't want that one also. Okay, I will see. I'm using of one formula. What is the formula? Is C2H6O. This is a formula. A compound having same molecular formula but having of different molecular structures. Molecular formula is same, but on this molecular formula, I am writing the one molecular structure. I am writing the structure is CH3, CH2, OH. See friends, how many number of carbon atoms? 2. How many number of hydrogens? 6. How many oxygen? Oxygen. Okay. Now I am writing the molecular structure. This is called as a molecular structure. It is a molecular formula. Now the name of this compound. How many number of carbon atoms are there? 2 are there. It. This is it. Okay. What is the functional group? OH alcohol means ethyl alcohol. This is the name is ethyl alcohol. See how is easy of name of the compound, organic compound. Once you got the concept is very important in the organic chemistry. So why the students are fearing the organic chemistry? Only because of they're not aware of the concepts. That's all only. If you are getting of the concept means you can play with organic chemistry. I'm sure about that one. Okay. So this is ethyl alcohol, same formula. I'm writing one more from this formula. One more molecular structure I'm writing. CH3O CH3. See friends here, how many number of carbon? 2 carbon atoms. Hydrogens, 6 hydrogens. Oxygen. This functional group is called as a ether. The functional group is called as a O is called as ether. How many number of methyl substituent? 1, 2. Means dimethyl. Dimethyl ether. This is the name of the compound. Now we are coming to the isomerism. A compound having the same molecular formula but different molecular structures. Different molecular structures, what happened? Ethyl alcohol properties entirely differ with the ether properties. Ether immediately evaporated. I keep on my palm. Immediately there is no ether at all. It is evaporated. But ethyl alcohol slowly evaporated. It is a wine you are using of. It is ether is a substance that is using in the laboratory reagent only. See, the physical and chemical properties are a lot of differences between the ethyl alcohol and ether, but both are having of same formula. These are molecular structure is called as isomers. Isomers means a compound is having of same molecular formula but different molecular structures is called as isomers. This phenomenon is called as isomerism. Right, friends? This isomerism or isomers are broadly classified into. The isomers are broadly your classification. The classification will be taken place. You are having of the mainly important of the classification is important here. Okay. Now I write the classification here only will get the total structure, the isomerism structures. Structural isomers. Structural isomers and stereoisomers. So friends, here the isomers are subdivided into two types: structural isomers, stereoisomers. It is also very important in the examination after the hybridization. Okay, stereo and structural. Structural isomers means what? The structurally the isomers are differing. That means there is a chance of like this straight chain, or there is a chance of the branched one. The structure is structurally changing one. This is called as a structural isomers. Stereo means there is a 180 degrees rotation will be takes place. Either like that. So I am having of this particular carbon will be rotated at 180 degrees. This is called as a stereo. The rotation around that particular compound in 180 degrees rotating. So that you are getting of stereoisomers. Okay. So the main important isomers are structural isomers and stereoisomers. The structural isomers further divided into chain isomers. Second is positional isomers. And third is functional isomers. Okay, I'm not talking about the stereo one. Just I'm talking about the structural. In the structural, again, the structural isomers are classified into chain isomers, positional isomers, and functional isomers. Okay, we are having our three metamers also there. That is not universal syllabus. So I'm using of only three isomers are there: chain, positional, functional. Chain means what, sir? The arrangement of the carbon atoms in the chain, it will be differs. That is called a chain isomer. The arrangement will be there in the compounds. In the chain form, the differing the carbon atoms. This is called as a chain isomers. But this chain isomerism is possible minimum the number of carbon atoms are present in a given organic compound must be 4 only, not less than 4. Means we are having the 1 is there, meth, 2 is there, eth, 3 is there, propane, methane, ethane. They do not form chain isomers. Only from the butane only you can get the chain isomers. Let us see the examples in the chain isomers. I will taking up the example of butane. N-butane means, what is the formula of N-butane? CnH2n plus 2 means 4. N is equal to 4 means C4H10. It is called as a N-butane. So friend, N-butane is a molecular formula. It is a molecular formula. I am writing the molecular structures for this N-butane. The first structure of the molecular formula, I am writing the skeleton. See the skeleton. Now I am writing. Number of carbon atoms are 4 are there. You can fill with the bonds with the hydrogen atoms. Here 3 more required the bonds are there. So I am filling with the 3 hydrogens. Here 2 more bonds are required. So that I am filling with the 2 hydrogen atoms. Here also 2 hydrogen atoms required, 2 bonds. Here 3 hydrogens required, 3 bonds are required. See the structure. 3, 2, 5, 7, 10 hydrogens, 4 carbon atoms. Okay, this is the N-normal butane. This is called as normal butane. This is a particularly butane structure formula. You can as a N-butane. Now the same formula I am writing. Why? Because structural means differ in the carbon chain. I am differ in the carbon chain. Just I am writing the one more carbon and the branched one. Now fill with the bonds. Here requiring of the 3 is required. Here 1, 2, 3 over. Only 1 hydrogen is required. Here 3 required. Okay. How many? 6 plus 1, 7 over. Remaining still is 3 is there. This is a 3. According to their nomenclature, what is there? 1, 2, 3 or 1, 2, 3. At the second position, one substitution is there. 2-methyl propane. Actually, but it is called as, in this particular chain isomer, isobutane. Why it is called as isobutane? The 1-methyl substance is present on the next second carbon. It is called as a isobutane. So this is the molecular formulas, molecular structure. This molecular formula is having of 2 molecular structure, that is called like chain isomers. But chain is differing. That's all. In the chain, if this is a straight chain, we are getting of the carbon atom is differ in the straight chain. That is called as a chain isomerism. Butane, pentane. I'm writing on the pentane on the top one. What is the formula of pentane? C5H12. It is a pentane. The pentane formula is C5H12. See, write the first one. First A, normally write it. 1, 2, 3, 4, 5. Fill with the bonds. 3 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, 3 hydrogens. C. Totally, it is called as normal pentane. Okay, I am writing one more. Just differing the carbon atoms. See the branch. Fill with that one. CH3, CH2. Here 3 is there. Only 1 is actually required. Here 3, here 3. That means here on the second position is there. EC is called as iso position, just like the butane, isopentane. Okay. Now write on the third one. I'm writing the third one. Carbon, carbon, carbon. 3 carbon atoms. I'm writing on the 2 more carbon atoms here. Fill with the bonds. CH3. Here 1, 2, 3, 4 is finished. CH3, CH3, CH3. See, total hydrogens are 12. 5 carbon atoms. Here on the same carbon, 2 substances called. It is called as a neopentane. See the name. Normal pentane properties are differ with the isopentane. Isopentane properties are differ with the neopentane. So third formula, that means pentane can exist how many chain isomerism? 3 isomers. Butane only 2 isomers are possible. Butane can obtain only 2 isomers, but the pentane can obtain 3 isomers. One isomer is called as N-pentane, second isomer isopentane, and also neopentane. Like that, you are getting of hexane. Hexane, you are getting of 5 isomers. Heptane, you can getting of 9 isomers. Octane, 18 isomers. Nonane, you are getting of 35 isomers. Decane, you will get the 75 isomers. Decane means C10H22. That formula is having of molecular structure, we will get the 75. If you are writing the today, you start today. If 75 structures, you will end by the after 1 year only. You will confuse 75 structural formulas you can write by the decade.
Board.
Okay. Sorry.
Fancy board, sir.
Repeat. I can repeat now.
Sir, move your camera up, sir. Upward, what you written, we can't see.
Okay. Now. Okay, ma. Right. So butane is getting off 2 isomers, ma. That is normal N-butane and isobutane. Pentane is getting off 3 isomers, N-pentane, isopentane, and neopentane. This is the third one. I'm written here only. Okay. It is called as neopentane. That means butane C4H8. Butane is getting off 2 isomers. Pentane is getting off 3 isomers. Hexane is getting off 5 isomers. These are the isomers are possible. Heftane, we are getting off 9 isomers. Octane, we are getting off 18 isomers. Nonane, you are getting off 35 isomers. Decane, you are getting off 75 isomers. Icoisane means C20H44. Icoisane is a name. 3,46,814 isomers. See the name. Icoisane C20. You are getting off 3 lakhs, more than the 3 lakhs you are getting off isomers. That is all already present. It is written by the scientists. That's why you are getting off this list. No need of this for examination point of view. Just for the knowledge purpose, I am written as this one. But the thing is, these are the important of the chain isomers. Okay. So friends, after the chain isomers, we'll go to the second is the positional isomers. We'll go to the positional isomers. Second is the positional isomers. What do you mean by positional isomers? Means the position of the functional group or substrate will be changing. Simply, the position of the that is a substrate. Let us see the example. I will explain with the example only. C3H7Cl, Nana. This is a molecular formula. This molecular formula I write as 1. State structure, number of carbon atoms are 3. Please remember, if in the examination they given a formula, write the molecular structure means. First remember the carbon atom, write the skeleton, write state structure, fill with the bonds. Here 3 required, here 2 required, 5 is over, remaining left only 2 are present, but here one more, still one bond is there. Why? Because 1, 2 means 3, still one more bond is, that bond is filling with the Cl. Now the name of the compound, please. Name of that compound. 1, 2, 3, sir. Means prop. It is a chloro. At what position is there chloro? You have to remember here. 1, 2, 3 only. So 1 chloropropane or chloropropane simply. This is 1 chloropropane. Now I am writing this changing. What is that? Changing the position of the functional group. This is functional substrate. Just write the simply first write here. Change the position. First is having of the first compound. First position is there. Now I am taking up the second position. And the second position the substrate is there. Now here 3 is there. 3. Here one more required. Totally 7. So it is called as 2 chloro propane called as positional isomerism. Positional isomerism is nothing but the position of the substance is changing one place to other place is called as the positional isomerism. So 1-chloropropane, this is called as a 2-chloropropane. Simply we are using of that formula, we are getting of the 1-chloro and 2-fluoro. That is a 2-chloro. Next we can try it C5H11Cl. Okay, so friends, make it sure that C3H8O if you want that one, or you can also take it as the C4H8 also. These are all are positional. See the simple. I will try the second that is a second example. What is second example? C5H11. Write the structure 5 CH2Cl. Keep it as CH2, 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 here CH3. Okay, 5, 7, 11. Sorry, 5, 7, 9, 11. 11 is over. 5 carbon atoms. This is called as 1-chloropentane. 1, 2, 3, 4, 5 position. Second, CH3, CH2, CH2, CHCl, CH3. It is called as 2-chloropentane. 1, 2, 3, 4, 5. Any chance? Still one more also chance. The position 1, 2, 3, 4, 5. Okay. At third position, I'm writing this one. CH3, CH2, CH, CH2, CH3. It is 3-chloropentane. Any chance? Fourth one. Here, keeping off here. Here is the both are same. Okay, the both will be same or present. That's why only the possible isomers are for the C5H11Cl is 3 possible isomers. 1-chloropentane, 2-chloropentane, 3-chloropentane only. That means if you are first you are changing the second, first you are next is the third position. Next, suppose if you are changing this position means from this side, first, second position again this one only. So like that you can write C3H8O, C4H8. I already written this one C4H8 already. Previously the example is given in the nomenclature. That only the formula is given. Okay, this is about the positional isomers. Now coming to the third one is functional isomers. Functional isomers. What is a functional isomer means? Only in the main chain the functional group it changes. First molecular structure is having of one of the functional group. Next molecular structure is having of different functional group is there. That is the case we are seeing already in the example of what the classified. And write a simple example of C2S6O. I explain the isomers with this example only. C2S6O. What I written as first one example is CH3CH2OH. OH is the functional group here. It is called as ethyl alcohol. Or we can call as ethanol. OL, ethanol. Is a calling as a ethanol. Okay. Now second, I am using of this functional group. This is the functional group here. Yes, I am saying of this functional group is changes to ether. This is the ether. The functional group is changes. So it is called as dimethyl. Two are there. Dimethyl ether. Here ether is a functional group. Here alcohol is a functional group. The functional group is changing. It is called as a functional isomers. Only functional group is changing. You are getting off this one. Okay. Like that you are having up the so many other compounds. C3S6O also. I will write. Why? Because it is already explained. But C3S6O. This is a molecular formula. Please try to write that one. Molecular formula. First, what is this first one? First straight chain. Fill with the bonds. 5 over. How many left? How many left? Only one hydrogen, one oxygen is left. One hydrogen, one oxygen. What occurred? You may think of star. It may be a OH. If OH means what you are, this is a carbon atom. How can you guide the bond? This particular carbon atom requiring of still 3 more bonds required. But any other functional group is there with the carbon atom, means think that one. If the carbon atom is there, one O is there, one oxygen is there, one hydrogen is there, one carbon is there, one hydrogen is there, one oxygen is there. Any functional group is present with this particular? That is nothing but, you can think as it is nothing but CHO, aldehyde. CH3, CH2. See the carbon atoms are 3 carbon atoms, 6 hydrogen atoms, 1 is this one. What is the name of the compound? Our numbering what? From this functional group is must be taken as a priority 1. 1, 2, 3. Propanoldehyde. Propanoldehyde. This is the first one. Or you can L as propanol. Al, not Ol. Al. This is a propanoldehyde. Now taken as the second one. The aldehyde group is changing. Means I am taking as CH3, CH, CH3. Means 6 plus 1. It is not there. Here I am using of 1, 6. 6 hydrogens are over, 3 carbon atoms are over, only 1 is there, oxygen is there. CO. What is the CO? What is the functional group? This one? It is nothing but ketone. So it is nothing but dimethyl. 2 methyls are there, dimethyl ketone. So friends, here nothing but what you are understanding in this particular example. In the first exam molecular structure, aldehyde is a functional group. In the second example, ketone is a functional group. Aldehyde ketones are bicarbonyl compounds, but the different properties. The molecular formula is same. This is called as a functional isomers. Okay, the functional isomers means like that. We are having of have to explain in the examination. This is all our structural isomers. Now coming to the main branch of stereoisomers. What are the stereoisomers? How they are classified? Next, that is a stereoisomers. Stereoisomers are broadly classified into geometrical isomers, or it is also called as cis-trans isomers. Geometrical also called as cis-trans isomers. Okay, and this is next is the optical isomers. So stereoisomers are broadly structural can be broadly classified in 3 categories, but the stereoisomers are broadly classified into geometrical isomers and optical isomers. Geometrical means there must be present of a double bond between the carbon and carbon. That means only unsaturated hydrocarbons only, unsaturated one. Means consisting of a double bond is present. Only those can undergo geometrical isomers. Only those can getting of the geometrical isomers. What are those geometrical isomers? Let us see the example, beautiful example. It is repeated again here also. C4H8. C4H8. What is the formula? Is C4H8 means it is a butene. Butene. Why it is butene? CnH2n. Alkene formula. 4 here, N is equal to 4 means C4H8. It is a butene. Now the butene is having of structure. That means what are the isomers are possible. This butene is, first I am writing the structure. First write this one. This is a very important in the geometrical structure. This is a skeleton in the geometrical structure. Any molecular formula is given. Any molecular formula is given. First you write this one. B also write this one. Please remember, friends, here I am using of this clue for this particular geometrical isomers. Why? Because sometimes it is asking for separate question as a geometrical isomers 5 marks question. Geometrical isomers compulsory. They are having of the carbon and carbon double bond is there. This is a skeleton formula structures. Why? Because it is a formula is given. This formula is having of the, you are getting of the molecular structures. Write the 2 molecular structures. Now keep this one. How many number of carbon atoms are there? 4 are there. Just I am keeping 1 carbon here, 1 carbon is here. The first A example, molecular structure, I am keeping the above the carbon atoms. Now fill the with the bonds because 4 carbon atoms are over. Now with the fill the with the bond means here you requiring of 3 hydrogens are required. Here 1 hydrogen is required. So total 4 is over. Here 3 is required. Here 1 is required. See friends, above 3, that is a 1, 2, 3, 4. This is a structure actually. This is a straight structure. Writing F like this. It is only. I am writing this in the form. This is a straight one. This is a form. Now see this one. And the carbon. This is a internuclear axis. Above the 2 methyl groups are there. Below the 2 hydrogen groups are there. Okay. This form is called as cis isomer. Cis isomers means only one side will be present. Those are called as the cis isomers. Now, but it is a compound. What is the name of this one? 1, 2. At the second position, this double bond is there. From this one, 1, 2. The second position is called as, it is nothing but 2-butene. It is 2-butene. Cis form is called as a 2-butene. Now come the cis second structure. Already I'm given as a skeleton one. Just first keep this one. This don't want to rotate. I already told that stereoism is rotate the 180 degrees. This compound will be rotating. If it is a rotating like this, so hydrogen comes top and the methyl groups is down. It is an angular, diagonally there. This is called as trans. Same is there. It is called as a cis. Diagonally, oppositely present. It is called as a trans isomer. This is a trans isomer. It is also called as 2-butene. Same, but is a cis position, it is a trans position. So please understand this particularly geometrical isomers, which is very important in this particularly geometrical isomer. We are writing off the substrate will be changing the rotation. That means second carbon atom will be rotated 180 degrees. We are getting off the trans isomer. That is called as a geometrical isomers. Okay, so this is a beautiful example. We are explaining with the geometrical isomers. Next, we will go to the one more example also there. If you are willing to write, that is a C2H2Cl2. I will write the example here, geometrical isomers. This is about the, I will explain that also, geometrical isomers. Next, optical, we will go to that one, optical. C2H2Cl2. Write the geometrical isomers. Suppose, what do you do? First, your duty is have every time explaining, but no one is take caring of this one. If any person is asking write the geometrical isomer, means given a formula. First, write 2 skeleton formulas. These are the 2 skeleton. These are the geometrical isomers. Now, keep in mind, how many hydrogens are there? 2 hydrogen. Just keeping these 2 hydrogens in the bottom. How many chlorines are there? Just here. Keep the ball. This is called as cis form. Now, keep like same one, Cl. Rotate 180 degrees. H top, chlorine bottom. This is called as a trans. No need to write the name also. If you are writing the cis isomer trans, it is called as a geometrical isomer. Now, you are naming of that one. So, first carbon, chlorine is there. Second carbon, chlorine is there. Means 1,2-dichloro. 1,2-dichloro. What is this? Is ethene. This is also same 1,2-dichloro ethene. Name is same, but it is a cis form, trans form. Okay, friends. This is about the molecular formula of that C2 of the geometrical isomers. Now coming to the optical isomers. What do you mean by the optical isomers? Optical isomers are nothing but very simple. Everyone, in the morning, you wake up the morning and bath na. Snanam chesi vacharu kada. Snanam cheyagane manam em chestam? బయటకు వచ్చి ముందు see your face in the mirror. What you get? Your image is appears. That image is nothing but optical isomers. The image is nothing but optical isomerism. That is nothing but mirror images. So friends, optical isomers are nothing but simple mirror images. Just I'm writing off. See, I'm writing what is fluoro, chloro, bromo, iodo. Carbon is there. In the carbon,
Methane.
if it is, this is what is this one? Methane.
Methane.
Removing of 4 hydrogens. I'm replacing 4 hydrogen in the halogens. So fluoro, chloro, bromo, iodo, methane. Fluoro, chloro, but you have to write according to the alphabetical order. Which one comes first? Bromo, chloro, fluoro, iodo, methane. This is a formula of one. I'm using of what is this? It is a mirror. So in the mirror, this chlorine comes here, and bromine like this, and iodine here, and the top fluorine is there. This is called as optical isomerism. Optical isomerism is nothing but the very simple. Only the mirror image is obtained. Those are called as optical isomer. So anybody, I mean, nobody will ask in the separate question, but the asking in the very important separate question as a geometrical isomerism only. Or else in the second, that is particularly long essay type, means isomers. So isomers means equal parts. Same molecular formula, but different molecular structure is called as isomers. These particular isomers are broadly classified into structural, stereo. The structural isomers further classified into chain compound, positional compound, functional isomers. And stereo isomers are classified into geometrical isomers, optical isomers. Chain means only in the chain differing. Particularly, only saturated hydrocarbons can be in, but the minimum number of carbon atoms are must be 4 carbon atoms will be present. From butane only, you are getting of the chain isomers. Butane can get 2 isomers, N-butane and isobutane. Pentane can obtain N-pentane, isopentane, neopentane, 3. Like that, you are having of number of is there. That is a chain isomers. Position means the position of the functional group or substrate will be changes one place to other place, is called as a positional isomerism. And functional means functional group itself it changes totally. If the one molecular structure is having the aldehyde, means next that functional group goes to the alcohol, maybe ether, maybe some other chances. The functional group it changes. Those are called the functional isomers. Coming to the geometrical means they're having of the only unsaturated hydrocarbons, means that particularly having of carbon between the carbon, a double bond is present. That only getting of the geometrical isomerism. In the first carbon atom, first carbon with the double bond does not rotate. The second carbon only rotate with the 180 degrees. So that you are getting of cis and transforms. That is called as a geometrical isomerism. Don't confuse. Any molecular formula is given. Write the skeleton formula, carbon, carbon, double bond, 4 bonds, 4 hands like that. Just for one carbon double bond. That means the carbon molecular formula is given compulsory 2 carbons must be there. Remaining other substrates, you can keep it as a one above the plane. That is called as a cis form. If the oppositely direction, it is called as a trans. That's all. Optical isomerism is just nothing but it's a mirror image only. This is about that one. And still we are having of after this one some classification of the reactions. Organic reactions are classified into how many types? The organic reactions are classified. Again, the question is a 5 marks question is asking. What are the organic reactions classification? Classification of organic reactions are nucleophilic reaction, electrophilic reaction, free radical reaction. Nucleophilic means minus, means that particular ion is a rich electrons are there. Always remember minus indicates rich ions. Electron is taken by that one. Okay. And electrophilic means it is a place. It is a electron deficient compounds. Electron deficient means less number of electrons are there. Those are called electrophiles. Nucleophiles. Free radical means a lone electron, unpaired electron, single electron, dot, you are putting as a dot. That is called as a free radical reactions. So reactions are classified into electrophilic reactions, nucleophilic reaction, free radical reaction. These are the types. Again, the polarity is there in that first chapter. That is the polarity you are having of inductive effect, mesomeric effect, resonance energy. Okay, these are the points which are having of the 5 marks questions. For your just I will explain that particularly which page number. I will tell that one page number. So page number 70, classification of organic reactions is there. Page number 70, that is the electrophilic reaction, nucleophilic reaction, and free radical reaction. Just remember, electrophilic means electron deficient. Nucleophilic means electron rich elements. Okay, free radical means lone electron, single electron is there. That is called as a free radical electrons. Okay, next is the polarity is there. The polarity, in that polarity of the molecules is inductive effect, mesomeric effect, inductive effect, mesomeric effect, resonance energy, hyperconjugation. These are the 4 are there. In that any 3 will be asked in the examination. For the 5 marks question, sometimes maybe all comes on the 4 will be getting off. Resonance energy, I will again explain in that particular topic is there. That means benzene is having of the resonance energy is a 36 kilocalories of energy. Why the resonance will be takes place means one bond is losing, we are getting off energy. Means requiring of some amount of energy. Then only the bond will be broken out. Otherwise, the bond does not work. If you are giving the some energy means that the energy will be required to remove the a bond, double bond. So that energy, what is energy called as a resonance energy? Why? Because there are particularly maximum number, that means highest is the resonance energy is the benzene only, that is requiring of 36 kilocalories of energy required to removing of 3 bonds from the benzene. So that is about this first unit. See, this the first unit is a very basic fundamentals. If you understand properly the first unit, the next unit what is alkanes. In that alkanes means already are 50% syllabus is covered in the first, that is the basics only. Alkanes means saturated hydrocarbons are. This is also called as paraffins are. Why it is called as a paraffins are? It is obtained from the petroleum products, natural products. The okay, paraffin means we are using of the wax candles. Okay, these are the CnH2n plus 2. It is a general molecular formula, sir. We are writing of ethane, methane, like that. So many are compounds. The sources of the alkanes are natural gas and petroleum. This is the natural sources of the alkanes obtained. How the preparation of the alkanes and properties of the alkane. Next is the cycloalkanes. What are the cycloalkanes? What is the preparation of cycloalkanes? In this Bayer-Stein theory is there and Saxe-Maurer theory is there. Okay, in the cycloalkanes. This is the second chapter. Third chapter is alkenes. Already you are classified. Alkene is CnH2n. In the alkenes preparation, this is alkenes also called as olefins. Olefins means it is a inertness. Double bond is present, so that it is called as inertness. So regarding that particular alkenes preparation is there. In that preparation, Setzeff rule is there, and the properties Markovnikov rule is anti-Markovnikov rule is there. Next, in the subtopic is alkadienes. How the alkadienes are classified? What are the preparation of the alkadienes? In that, the important chemical properties Diels order reaction. For this is the organic part. So we'll discuss about the alkanes and alkenes in the next class. Okay. So friends, this organic part totally, actually for your SEM, it is getting off the 30 marks from this black. 30 marks from this black. Remaining 2 marks only you can get from the other black. 30 marks is very important. But actually in the regular stream, suppose year wise is there from only organic part, 50 marks, only organic part. That much of questions are there. That much of importance is given to this organic part. But after the dividing of the SEM system, you are equally distributed the marks in each block. So you will get the 30 marks from this block. Right? Any more doubts? Somebody is asking.
Sir.
Okay. So already time up. 50 more extra minutes already were covered for that one. Next, you ready with the next class? Okay. Bye.
Sir, when we have exams, sir?
Which exams, Amma?
Sir, exams for
This first year SEM exams. Oh, plenty of time is there, Amma. No problem for that one. You are having enough sufficient time, madam. Sufficient time is there. Prepare yourself, and whatever the your lesson is, just prepare your own notes and read out every day. Just glance. Don't misuse. That means after the class, finishing the class, keep the particular book in the rack or cupboard. Don't do like that. Whatever the time is getting, you can just refresh it. Then you will getting off the time. I hope that this particular maybe in the month of May or in the month of June, maybe that is our first year exams, or sometimes maybe immediately away, because you can conduct the practical classes, practical exams. That is important to you. Meanwhile, after the finishing of the March, they will start the practical classes also. After the finishing of the practical class, you are getting of the April or May, the exams may be getting. Okay? Right, ma?
Thank you, sir.
Okay.
Thank you, sir.
Hey, agu. Follow one agu.